Hello, in this lecture we will find out the area of the semicircle using 4 different methods. In the drawing we have a semicircle that is inscribed by a triangle. Triangle ABC is a right triangle. This angle ABC equals to 90 degrees. Side CB of triangle ABC equals to 5 units. Side AB equals to 12 units. And we want to find out the area of this semicircle. So we will start with the first method. And first of all, we will define the center of this semicircle as point O. Line segment OB. This line segment is the radius of this semicircle because of the fact that line segment OB starts from the center of this semicircle and ends at point B, that is a point on the semicircle itself. Therefore, OB is the radius of this semicircle, and we will define the radius of this semicircle as R. Therefore, OB equals to R. And AO, line segment AO equals to AB minus OB. Again, AB minus OB equals to AO. So I'll write it down. AB minus OB equals to AO. But we know that AB equals to 12 units. It is given us the question. And OB is R, the radius of the semicircle. So AO equals to 12 minus R. AO equals to 12 minus R. I'll repeat again. AO equals to AB minus OB. AB is 12 units and OB is R, so AO equals to 12 minus R. In the next step, we will define the point of tangency of tangent CA with this semicircle as point D. Again, point D is the point of tangency of tangent AC with this semicircle. Then we will join points O and D together by a straight line. OD is the radius of this semicircle because of the fact that line segment OD starts from the center of the circle, that is to say from the center of the semicircle, that is to say from point O, and ends at point D, that is a point on the semicircle itself. Therefore, OD is the radius of this semicircle, that is to say it equals to R. In the next step, we will find out the length of the hypotenuse AC of the right triangle, triangle ABC. So we will focus on the right triangle, triangle ABC. So in the right triangle, triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle, triangle ABC, is AC. So the square of the hypotenuse is AC squared, and AC squared, it equals to the sum of the squares of the perpendiculars. That is to say, it equals to CB squared plus AB squared. I will repeat again. In the right triangle, triangle ABC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square equals to CB square plus AB square. So actually AC square equals to CB square. We know that CB equals to 5 units, so CB square is 5 square, and 5 square is 25, plus AB square. AB equals to 12 units, it is given as the question, so AB square is 12 square, and 12 square is 144. So in conclusion, we got that according to equation number 1, AC square equals to 25 plus 144. 25 plus 144 is 169, so I will write it down. We found out that according to equation number 1, AC square equals to 169. Here we will take a root out of this equation, equation number 1, and we will get that AC equals to the square root of 169, and the square root of 169 equals to 13. So we found out that AC equals to 13 units. So the hypotenuse of the right triangle, triangle ABC, equals to 13 units. So we can write here that AC equals to 13 units. And in the next step, I will present to you a new rule. Rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So I will repeat on rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have a circle And the center of this circle is at this point. We define the center of the circle as point O. And we also have tangent AB to this circle. Here, tangent AB, this tangent is tangent to this circle at this point. We define the point of tangency as point M, so point M, this point, is defined as point of tangency of tangent AC with this circle. Okay, and we will join points O and M together by a straight line. OM is the radius of this circle, and according to rule number 1, a tangent to a circle, that is to say AB is the tangent of this circle, is perpendicular to the radius drawn to its point of tendency. So OM is the radius of this circle, and we have the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, the tangent AB is perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So whenever you have a radius that is drawn to the point of tendency, like in this drawing we have the radius OM that is drawn to the point of tendency, that is to say this radius drawn to point M, that is the point of tendency. Therefore, the tangent AB will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? So we can actually implement rule number 1 in our drawing. In our drawing, we know that CA, tangent CA, is tangent to this semicircle at point D. Point D is the point of tendency of tangent CA with this semicircle. And we have the radius OD that is drawn to the point of tendency. That is to say the radius is drawn to the point of tendency, that is to say it is drawn to point D, that is the point of tendency of tendency A with this semicircle. Therefore, according to rule number 1, whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius. So the tangent CA will be perpendicular to this radius. That is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? And because of the fact that angle ADO is a right angle, it equals to 90 degrees, therefore triangle ADO is a right triangle. The green triangle ADO is a right triangle because it has one angle that equals to 90 degrees. So in the next step, we will prove that the right big triangle, triangle ABC, is perpendicular to the small right green triangle, triangle ADO. Okay, so we will focus on the right big triangle, triangle ABC. and the green right small triangle, triangle ADO. And we will prove that those two triangles are similar to each other. So why they are similar to each other? First of all, those two angles, they are both right angles, therefore they are equal to each other. So this angle, that is angle ABC in triangle ABC, is equal to this angle, that is angle ADO in the green triangle. Okay, and we also have this angle is a common angle that belongs both to triangle ABC and it also belongs to the green triangle. Therefore, angle A equals to angle A. It's a common angle that belongs to both triangles. Angle A equals to angle A. It's a common angle. I'll repeat again. Angle A equals to angle A. It's a common angle that belongs to both triangles. And we also have those two angles, they are also equal to each other according to third angle theorem. So this angle, that is actually angle ACB in triangle ABC, is equal to this angle, that is actually angle AOD in the green triangle. And those two angles, they are equal to each other according to third angle theorem. Okay, angle ACB in triangle ABC is equal to angle AOB in the green triangle according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And if we have those two angles in triangle ABC congruent to those two angles in the green triangle. So we have in those two triangles two pairs of angles that congruent. Therefore, according to third angle theorem, the third pair of angles must also congruent. Those angles are defined as the third pair of angles, and they must also congruent because of the fact that they are complementary to 180 degrees. We know that the sum of the angles in any triangle is equal to 180 degrees, and if we have two angles that are equal in two triangles, then the third pair of angles that are complementary to 180 degrees must also congruent. Okay? So we actually found out that all three angles in triangle ABC congruent to all three angles in the green triangle. Therefore, we actually proved that triangle ABC is similar to triangle ADO, the green triangle, according to angle similarity rule. So I'll write it down. We actually proved that triangle ABC is similar, this is the sign of similar, to triangle ADO, the green triangle, according to angle similarity rule. I'll repeat again. We proved that the big triangle ABC, is similar to the green small right triangle ADO, according to angle similarity rule. What is angle similarity rule? Angle similarity rule is that if you prove that all angles in one triangle congruent to all angles in another triangle, then those two triangles will be similar to each other according to angle similarity rule. And from the fact that the big triangle ABC, is similar to the green triangle ADO, we will conclude that CB over CA in triangle ABC equals to DO over AO in the green triangle. Okay, so I repeat again. From the fact that triangle ABC is similar to triangle ADO, we will conclude that CB over CA in the big triangle, the big right triangle ABC, is equal to DO over AO in the green triangle, the green right triangle ADO. But we know that CB equals to 5 units. We have already found out that CA, the hypotenuse of triangle ABC, equals to 13 units. DO is the radius of the semicircle, that is to say it equals to R, and AO equals to 12 minus R. So we found out that according to equation number 2, 5 over 13 equals to R over 12 minus R. Here we will cross multiply equation number 2 and we will get that 5 times 12 minus R equals to 13R. Here we will open the brackets of this side of equation number 2 and we will get that 5 times 12 equals to 60. 5 times minus R equals to minus 5R. And it equals to 13R. Here we will add 5R to this equation number 2, and we will get that 13R plus 5R, according to equation number 2, 13R plus 5R equals to 18R. And here we have 5R minus 5R is 0, so we left only with 60. So we found out that according to equation number 2, 18R equals to 60. We will divide this equation number 2 by 18. We will divide equation number 2 by 18. And we will get that the radius of the semicircle R equals to 60 over 18. Here we will divide this, we will divide both the numerator and the denominator of this number by 6, and we will get that 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle according to equation number 2 equals to 10 over 3 units. And the area of the semicircle actually here the brackets are the sign for the area. It means the area of the semicircle equals to pi r square over 2. So it is pi and r is 10 over 3. R square is 10 over 3 square over 2 equals to pi. 10 over 3 square is 100 over 9, all divided by 2. And here 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, so we finished with the first method. In the next step, I will present to you how to find out the area of the semicircle according to a second method. Okay. In the second method, first of all, we have already found out that this point is point D. DO is the radius of the semicircle, and this angle is 90 degrees, and this angle is also 90 degrees. Here it is OB. OB equals to R. AO equals to 12 minus R. AC, the hypotenuse of triangle ABC, equals to 13 units. Okay. And here I will present to you rule number 2, or two tangents theorem, and we use two tangents theorem in order to find out the area of the semicircle. So what is rule number 2, or two tangents theorem? According to rule number 2, or two tangents theorem, a tangent to the length of two tangents from a common external point to a circle are equal. So I will read rule number 2, or two tangents theorem again. According to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 2, or two tangents theorem? Actually, if we have a circle and we have an external point, point P, here point P is an external point of this circle. Why point P is an external point? Because point P is not located inside this circle nor on this circle, but it is located outside of this circle. Therefore point P is defined as an external point of the circle. So if from the external point P we will draw two tangents to this circle, then the first tangent will be this tangent, and we will define the point of tangency of the first tangent with this circle as point A, and we will also draw the second tangent to this circle, and the second tangent is tangent to this circle at this point. We'll define the point of tangency as point B, and according to two tangents theorem, the lengths of two tangents, the length of the first tangent is PA, the length of the second tangent is PB, and according to two tangents theorem, the lengths of two tangents from a common external point, that is to say from point P that is a common external point, to a circle are equal. So according to rule number 2 or two tangents theorem, the lengths of those two tangents, that is to say PA and PB, are equal to each other. That is to say PA equals to PB. PA equals to PB according to two tangents theorem. So whenever you draw from a common external point of a circle two tangents to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA will be equal to PB. Okay, so we actually can implement two tangents theorem in our drawing, because in our drawing we have the external point, point C, and from the common external point, point C, we have two tangents to this semicircle. The first tangent is tangent CB. Tangent CB is tangent to the semicircle at point B. And we have the second tangent, that is tangent CD. Tangent CD is tangent to this semicircle at point D. And according to two tangents theorem, the lengths of those two tangents are equal to each other. That is to say, CB equals to CD. Okay, according to two tangents theorem, CB equals to CD. Okay, rule number 2 of two tangents theorem. I repeat again. According to two tangents theorem, CB equals to CD. But we know it is given us in the question that CB equals to 5 units. Okay, CB equals to 5 units according to what is given us in the question. So from this equation we will derive that CD also equals to 5 units. Okay, CD also equals to 5 units. Okay, so here we can write down that CD equals to 5 units. But we have already found out that CA equals to 13. We found out that CD equals to 5, so DA will be equal to CA minus CD. Again, DA equals to CA minus CD. I will write it down. DA equals to CA minus CD. So DA equals to CA equals to 13 units. We just right now found out that CD equals to 5 units. So in conclusion, we found out that DA equals to 13 minus 5. That is to say it equals to 8 units. dA equals to 8 units, we can write here that dA equals to 8 units. So in the next step, we will focus on the right triangle, triangle ADO, or the right green triangle, triangle ADO. And we will implement the Pythagoras theorem on the right green triangle, triangle ADO. So according to the Pythagoras theorem, on the right green triangle, triangle ADO, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the green triangle, green right triangle, it is actually AO because it is in front of the right angle. So the square of the hypotenuse is AO square, and it equals to the sum of the squares of the perpendiculars. That is to say, we know that DO is R, we found out in method 1. So it equals to the sum of the squares of the perpendiculars. That is to say, it equals to DO square plus dA square. I will repeat again. In the right triangle, triangle ADO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AO square equals to DO square plus dA square. Okay. We have already found out that AO equals to 12 minus R, therefore AO square is 12 minus R square. And it equals to the sum of the squares of the perpendiculars, that is to say it equals to DO square. DO equals to R, so DO square will be equal to R square plus dA square. dA equals to 8, so dA square is 8 square, and 8 square is 64. So here we will open the brackets on this side of equation number 1, and we will get that 12 minus R square equals to 12 square is 144 plus R square minus 24R equals to R square plus 64. So here we have R square on both sides of equation number 1, so R square will get cancelled. And what is left from equation number 1 after we cancelled R square? What is left? It is actually, here we have 144 minus 24R. On the other side, we have the equation, we have only 64. Here we will subtract 64 from this equation, equation number 1, and we get that 144 minus 64 is 80. 80 minus 24R equals to 0. Here we will add 24R to this equation, equation number 1, and we will get that 84R equals to 80. Here we will divide equation number 1 by 24, and we will get that the values of the semicicle R according to equation number 2, according to equation number 1, equals to 80 over 24, and we can divide both the numerator and the denominator of this number by 8, and we get that 80 over 8 is 10 and 24 over 8 is 3. So in conclusion, we found out that according to equation number 1, the radius of the semicircle equals to 10 over 3 units, and therefore the area of the semicircle will be equal to pi r squared over 2. So it is pi over 2 times r is 10 over 3, and r squared is 10 over 3 squared, and it equals to pi over 2. 10 over 3 squared is 100 over 9. So here we have 100 over 2 is 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the second method. In the next step, I will present to you how to find out the area of the semicircle according to a third method. So actually, in the third method, first of all, in the third method, we will draw the mirror image of this figure, and then we will join this figure with its mirror image, and in this way we will create a circle that is inscribed by an isosceles triangle. Okay, so we will draw the mirror image of this figure, and we will join those two figures together, and we will create an isosceles triangle that blocks the circle. So here we actually joined the original figure with its mirror image together, and in this way we created an isosceles triangle that blocks this circle. We already found out that AC, the hypotenuse of triangle ABC, equals to 13 units, BC equals to 5 units. It is given us in the question. We define this point as point D, and because of the fact that this figure is a mirror image of this figure, so because, and AC equals to 13 units, then AD also must be equal to 13 units. Likewise, we know that BC equals to 5 units, and this is the mirror image of this figure, so DB must be also equal to 5 units, and therefore DC, the base of the isosceles triangle ADC, will be equal to 5 plus 5, that is to say, it will be equal to 10 units, and the area of the isosceles triangle ADC will be equal to the base of triangle ABC, to the base of triangle, the isosceles triangle ADC, times the height to the base. We know that AB equals to 12 units. This is actually the height to the base, because the height AB creates 90 degrees with the base. You can see it here. So times the height to the base, that is actually AB over 2. So the area of the isosceles triangle ADC will be equal to the base of this isosceles triangle ABC is DC, and the height to the base is AB, because the height AB creates 90 degrees with the base, therefore it is the height. So the height is AB over 2. So the area of the isosceles triangle ADC will be equal to the base, that is DC, that is the base, it equals to 10 units, times the height AB, that equals to 12 units, over 2. 10 times 12 is 120, and 120 over 2 is 60. So we found out that the area of triangle ADC, the isosceles triangle ADC, equals to 60 square units. And we also know that the radius of a circle that is inscribed by a triangle, like in this figure, the radius is equal to the area of the triangle that blocks the circle, that is to say the area of triangle ADC, over the semi-perimeter of the triangle that blocks the circle, that is to say the semi-perimeter of triangle ADC. And what is the semi-perimeter of any triangle? The semi-perimeter of any triangle is equal to the perimeter of the triangle over 2. And the perimeter of triangle ADC equals to AD plus AC plus DC over 2. AD plus AC plus DC is the perimeter, and if we will divide the perimeter by 2, we will get the semi-perimeter. Okay? Okay, so AB plus AD plus DC over 2 is the semi-perimeter of triangle ADC. AB is 13, AC is 13, and DC is 10, all divided by 2, so 13 plus 13 is 26, and 26 plus 10 is 36, and 36 over 2 is 18. So we found out that the semi-perimeter of triangle ADC equals to 18 units. So the radius of the semicircle that is actually is right here. The radius of the circle that is inscribed by a triangle is equal to the area of the triangle that blocks the circle, that is to say the area of triangle ADC, over the semi-perimeter of triangle ADC. I repeat again, the radius of a circle that is inscribed by a triangle is equal to the area of the triangle that blocks the circle over the semi-perimeter of the triangle that blocks the circle. And the area, we already found out that the area of triangle ADC equals to 60 square units. And we already found out that the semi-perimeter of triangle ADC equals to 18 units. So 60 over 18, we will divide both the numerator and the denominator of this number by 6. And we will get that 60 over 6 is 10. And 18 over 6 is 3. So we found out that the radius of the circle, that is also the radius of the semicircle, equals to 10 over 3, because of the fact that the circle is composed from two identical semicircles. Again, the circle is composed, our circle is composed with two identical semicircles, our semicircle that the area of it we want to find out. Therefore, the radius of the circle will be equal to the radius of the semicircle because of the fact that it is composed from the two semicircles that combine together in order to create the circle. So the radius of the circle equals to the radius of the semicircle, that is actually 10 over 3 units, and the area of the semicircle, this is the sign of the area of the semicircle equals to pi r square over 2, pi, and r is 10 over 3, r square is 10 over 3 square over 2, so it is pi over 2. 10 over 3 square is 100 over 9. 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, we finished with the third method. In the next step, I will present to you how to find out the area of this semicircle according to the fourth method. Okay? And in the fourth method, here we know that this is point O, this is R, this is 12 minus R. This is D. OD is the radius of the semicircle. And this angle is a right angle, and this angle is also a right angle. DO is R. AC equals to 13 units. So we will define this angle that near vertex A is theta, and what is the value of, if you focus on the right triangle ABC, on the right triangle ABC, sinus theta can see here that sinus theta equals to CB over CA. Again, in the right triangle, triangle ABC, sinus theta equals to CB over CA. But we know that CB equals to 5 units, it is given us in the question. And we have already found out that CA equals to 13 units, it is the hypotenuse of triangle ABC. So in conclusion, we found out that according to equation number 1, sinus theta equals to 5 over 13. Okay, here, sinus theta equals to 5 over 13 according to equation number 1. In the next step, we will focus on the right triangle, triangle ADO. On the right triangle, triangle ADO. The right ring triangle, triangle ADO. In the green triangle, triangle ADO, sinus theta will be equal to DO over AO. Again, in the green right triangle, triangle ADO, sinus theta equals to DO over AO. But we know that DO equals to R and AO equals to 2F minus R. So in conclusion, we found out that according to equation number 2, sinus theta equals to R over 2F minus R. Okay, according to equation number 2, sinus theta equals to R over 2F minus R. In the next step, we will create equation number 3. According to equation number 3, sinus theta, according to equation number 1, that is actually 5 over 13, must be equal to sinus theta according to equation number 2, that is R over 12 minus R. So I will repeat on equation number 3. Equation number 3 states that sinus theta according to equation number 1, that is 5 over 13, equals to sinus theta according to equation number 2, that is actually R over 12 minus R. So here we will cross multiply equation number 2 and we will get that five times 12 minus R equals to 13R. Here we will open the brackets on this side of equation number 2 and we will get that 5 times 12 is 60 and 5 times minus R is minus 5R and it equals to 13R. Here we will add to this equation number 3, 5R, and we will get that 13R plus 5R equals to 18R, and 18R equals to 60. Here we will divide equation number 3 by 18, and we will get that the radius of the semicircle equals to 60 over 18. Here we will divide both the numerator and the denominator of this number by 6, and we will get that 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle, according to equation number 3, equals to 10 over 3. And therefore, the area of the semicircle will be equal to the area of the semicircle will be equal to pi r square over 2. So it is pi over 2, r is 10 over 3, and r square is 10 over 3 square. So it is pi over 2, and 10 over 3 square is 100 over 9. And pi over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 units, over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay? So in the next step, I will summarize the lecture. We found out the area of this semicircle according to 4 different methods. In the first method, we have here a semicircle that is inscribed by a right triangle, triangle ABC. CB equals to 5 units, AB equals to 12 units, angle ABC equals to 90 degrees, and you want to find out the area of the semicircle. We defined the center of the semicircle as point O, OB is R, AO here AO equals to AB minus BO. Again, AO equals to AB minus BO. AB is 12 units, BO is R, so AO equals to 12 minus R. Then we focused on triangle ABC, and we found the hypotenuse according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square equals to CB square plus AB square. So AC square equals to CB square. CB is 5, so CB square is 5 square. 5 square is 25, plus AB square. AB is 12. AB square is 12 square. 12 square is 144. So in conclusion, we found out that according to equation number 1, AC square equals to 25 plus 144. 25 plus 144 is 169. So we found out that according to equation number 1, AC square equals to 169. We took a root out of this equation number 1, and we got that AC equals to the square root of 169, and the square root of 169 is 13. So we found out that AC, the hypotenuse of triangle ABC AC, equals to 13 units. Then I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and we have tangent AB that is tangent to this circle at point M. Point M is the point of tendency of tangent AB with this circle, and we have the radius OM. The radius OMR, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, the tangent AB will be perpendicular to this radius according to rule number 1. That is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. That is rule number 1, and we implemented rule number 1 in our drawing, because in our drawing we have here point D is the point of tendency of tangent AC with this semicircle, and we have the radius OD that is drawn to the point of tendency, that is to say, it is drawn to point D, that is the point of tendency A with this semicircle. Therefore, the tangent CA will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And because of the fact that this angle equals to 90 degrees, it means the triangle ADO is a right triangle. And we can implement, here we actually proved that the triangle ABC is similar to the green right triangle, triangle ADO. Why they are similar to each other? First of all, we have those two angles, they are equal to each other, they are both equal to 90 degrees. This angle is a common angle, it belongs to both triangles, so this angle equals to itself, it's a common angle that belongs to both triangles. And those two angles, they are also equal to each other according to third angle theorem. For this third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And we have those two angles in triangle ABC congruent to those two angles in the green triangle, triangle ADO. So we have two pairs of angles that congruent in those two triangles, therefore the third pair of angles, that is to say, those two angles must also congruent according to third angle theorem because of the fact that they are complementary to 180 degrees. Okay, so we actually proved that all three angles in triangle ABC congruent to all three angles of the green triangle, triangle ADO. Therefore, we proved that triangle ABC is similar to triangle ADO according to angle similarity rule. And from the fact that triangle ABC is similar to triangle ADO, we will conclude that CB over CA in triangle ABC is equal to DO over AO in triangle ADO, the green triangle. CB is 5, CA is 13, DO is R, and OA is 12 minus R. So in conclusion, we found out that according to question number 2, 5 over 13 equals to R over 12 minus R. Because multiply the question number 2. When we got that 5 times 12 minus R equals to 13R, we open the brackets on this side of equation number 2, and we got that 5 times 12 equals to 60, and 5 times minus R equals to minus 5R. Here we added 5R to this equation number 2, and we got that 13R plus 5R is 18R, so 18R equals to 60. We divided this equation number 2 by 18, and we got that the radius of the semicircle equals to 60 over 18. We divided both the numerator and the denominator of this number by 6, and we got that 60 over 6 is 10, and the 18 over 6 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units, and therefore the area of the semicircle, this is the sign for the area of the semicircle equals to pi r square over 2, that is to say it equals to pi over 2 times r, that is 10 over 3, and r square is 10 over 3 square, and 10 over 3 square equals to 100 over 9, so we have pi over 2 times 100 over 9. Here 100 over 2 is 50, so in conclusion we found out that the radius of the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers it equals to 17.45 square units. So we finished with the first method, and in the next step I'll present it to you how to find out the area of the semicircle according to a second method. In the second method, I presented to you rule number 2, or 2 tangents theorem. According to rule number 2, or 2 tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 2? The meaning of rule number 2 is if we have this circle and we have the external point P of this circle, from the external point B we draw two tangents to this circle. The first tangent is PA, the second tangent is PB. So the length the lengths of those two tangents will be equal to each other. Why? Because whenever you draw two tangents to a circle from an external common point of that circle, then the lengths of those two tangents will be equal to each other. In this case, PA will be equal to PB. We can implement rule number 2 of two tangents theorem in our drawing, because in our drawing we have the external point C, and from the external point C we have the first tangent that's CB and the second tangent is CD. And according to rule number 2 of two tangents theorem, the lengths of those two tangents are equal to each other. That is to say, CB equals to CD. CB equals to CD according to rule number 2. But we know that CB equals to 5 units. It is given as the question. So from this equation, we will derive that CD also equals to 5 units. CD equals to 5 units. And what is the value of DA? DA equals to AC minus DC. Again, dA equals to AC or CA minus CD. CA is 13, CD is 5. Therefore, dA equals to 13 minus 5. That is to say, dA equals to 8 units. dA equals to 8 units. So we found out that dA equals to 8 units. Then if you focus on the green right triangle, triangle ADO, we implemented the Pythagoras theorem on the green right triangle, triangle ADO. According to the Pythagoras theorem in the green right triangle, triangle ADO, AO square equals to DO square plus DA square. AO is 12 minus R. Therefore, AO square is 12 minus R square. That equals to DO. DO square. DO is R, so DO square is R square. AD is 8. Therefore, AD square is 8 square. 8 square is 64. So in conclusion, we found out that 12 minus R equals to R square plus 64. We open the brackets on this side of equation number 1. And we got that 12 minus R square equals to 12 square is 144 plus R square minus 24R. That equals to R square plus 64. We have R square on both sides of equation number 1. So R square is here cancelled. And we left only with 144 minus 24R, that equals to 64. Here we subtracted 64 from this equation, equation number 1, and we got that 144 minus 64 is equal to 80. So in conclusion, we got that 80 minus 24R equals to 0. We added 24R to this equation number 1, and we got that 24R equals to 80. Then we divided this equation number 1 by 24, and we got that R equals to 80 over 24. We divided both the numerator and the denominator of this number by 8, and we got that 80 over 8 is 10, and 24 over 8 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units, and therefore the area of the semicircle equals to pi r squared over 2. So it is pi over 2, and r equals to 10 over 3. Therefore, r squared will be equal to 10 over 3 squared. So it is pi over 2, and 10 over 3 squared is 100 over 9. And in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the second method. Then I presented to you how to find out the area of the semicircle according to a third method. In the third method, I drew the in the second method, I drew the mirror image of this. I drew the mirror image of this figure, and then I joined this figure with its mirror image, and in this way we created a circle that is inscribed by a triangle. Okay, I'll repeat again. I drew the original image, the original figure, and the mirror image of the original figure, and in this way we created a circle that is inscribed by an isosceles triangle, triangle ADC. Okay? And then, because of the fact that this is the mirror image of this figure, so if AC is 13, then AD must be also equal to 13, BC is 5, so DB must be also equal to 5, and AB equals to 12, CD equals to 5 plus 5, that is to say the base of the isosceles triangle, triangle ABC equals to 10 units, and then we calculated the area of the isosceles triangle, triangle ADC. The area of the isosceles triangle, triangle ADC equals to the base of the triangle times the height to the base over 2. The base is DC, the height is AB over 2. So DC equals to 10 units, AB equals to 12 units, all divided by 2. 10 times 12 is 120, and 120 over 2 is 60. So we found out that the area of the isosceles triangle, triangle ADC equals to 60 square units. And then we know that the radius of any circle that is inscribed by a triangle equals to the area of the triangle that blocks the circle over the semi-perimeter of the triangle. And we already found out that the area of triangle ADC equals to 60 square units, and the semi-perimeter of triangle ADC equals to the perimeter over 2, and the perimeter is AB plus AC plus DC, all divided by 2. So AB is 13, AC is 13, DC is 10, all divided by 2. 13 plus 14 is 26, 26 plus 10 is 36, 36 over 2 is 18. So we found out that the semi-perimeter of triangle ADC equals to 18, and the area is 60 square units. Therefore, the radius of the semicircle that is blocked by triangle ADC equals to the area of triangle ADC of the semi-perimeter of triangle ADC. That is to say the area of triangle ADC is 60 square units, and the semi-perimeter of triangle ADC is 18. So 60 over 18 is 10 over 3. So we found out that the radius of the semicircle equals to 10 over 3 units. Therefore, the area of the semicircle equals to pi r square over 2. So it is pi over 2, and r is 10 over 3, so r square is 10 over 3 square. 10 over 3 square is 100 over 9, so it is pi over 2 times 100 over 9. 100 over 2 is 50, so in conclusion we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the first method, and at the end I presented to you how to find out the area of the semicircle according to a fourth method. In the fourth method, we defined this angle CAB as theta. Then we focused on triangle ABC, and sinus theta in triangle ABC equals to CB over CA. Again, sinus theta in triangle ABC equals to CB over CA, that is to say CB is 5, CA is 13. So in conclusion, we found out that sinus theta equals to 5 over 13 according to equation number 1. And then we focused on the green triangle, green right triangle, triangle ADO. Here sinus theta will be equal to DO over AO. Here sinus theta equals to DO over AO. DO is R, AO is 12 minus R. So in conclusion, we found out that sinus theta according to equation number 2 equals to R over 12 minus R. Then we created equation number 3 that states that sinus theta according to equation number 1 equals to sinus theta according to equation number 2. So sinus theta according to equation number 1 is 5 over 13. It must be equal also to sinus theta according to equation number 2, that is R over 12 minus R. So here we first multiplied the equation number 3, and we got that 5 times 12 minus R equals to 13R. We open the brackets on this side of equation number 3 and we got that 5 times 12 is 16, 5 times minus r is minus 5r, it equals to 13r. We added 5r to this equation number 3, and we got that 13r plus 5r is 18r. So 18r equals to 60 according to equation number 3. We divided equation number 3 by 18, and we got that r equals to 60 over 18. Here we divided both the numerator and the denominator by 6. 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3 units, and the area of the semicircle equals to pi r square over 2, and so it is pi over 2, and r is 10 over 3, and r square is 10 over 3 square. 10 over 3 square is 100 over 9. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, thank you very much.